All right, strap yourselves in because today we are diving deep into some seriously awesome science.
Sounds good.
We've got an article here, hot off the press, December 22nd, 2024, all about NASA's Parker Solar Probe. And get this,
Yeah.
it's going to be flying closer to the sun than anything we've ever sent before.
Yeah, it's really exciting stuff.
I know. Like, we're basically right there with the mission team,
Right?
just waiting on bated breath for that data.
It really is incredible.
It is incredible.
The Parker Solar Probe is a real testament to engineering, to be able to withstand that amount of heat and radiation.
Absolutely.
It's just mind-blowing.
Yeah, it's not just like taking a few pictures on a quick flyby.
Right.
It's packed with all these instruments to study the sun.
Yeah, it's got an impressive payload on there.
Yes, and all this is part of NASA's Living with a Star program,
Exactly.
which I think is important because it reminds us that understanding the sun isn't just about,
Yeah.
satisfying our scientific curiosity. It really is about understanding this celestial body that has such a huge influence on our planet,
Yeah,
our lives.
exactly. I mean, the sun is a pretty powerful neighbor.
Yeah.
And we need to understand it better.
You're making it sound like the sun is a bit of a frenemy.
Well, it gives us life, but it can also throw some pretty rough stuff our way.
Yeah, you're talking like solar flares, coronal mass ejections.
Yeah, all those things
Well,
that
there.
can really wreak havoc on our technology,
Right.
our power grids,
Yeah.
communication systems.
Yeah, so it sounds like the more we know,
Yeah,
the better we can predict when these solar storms are coming
absolutely.
and try to, prepare.
Exactly. Early warning is key.
Yeah, absolutely.
So, speaking of this close encounter,
Yeah.
mark your calendars
Oh, okay.
for December 24th.
Oh, wow. Christmas Eve with the Parker Solar Probe.
That's right.
That sounds kind of fun, actually.
Yeah.
How close are we talking about here?
So Parker's going to be a mere 3.8 million miles from the sun's surface.
3.8 million miles.
Yeah.
Okay. I can't even conceptualize that number. Can you give me like something to compare it to?
Yeah, so that's about 9 times closer than Mercury,
Oh, wow.
which is the closest planet to the sun.
Okay. Yeah, that puts it in perspective.
Yeah.
Wow. I'm starting to feel a little warm just thinking about it.
Yeah, it's a pretty intense environment.
But I mean, if it's that close,
Yeah.
how can it even talk to us back on Earth?
Well, that's the catch.
Okay.
During its closest approach,
Yeah.
communication is impossible.
Oh, wow.
It basically flies into this radio blackout zone.
Oh, so it's really venturing out there alone
Yeah.
into the unknown.
It's a daring mission.
Yeah. When do we actually get to hear back from it?
So we have to wait until December 27th
Okay.
for it to basically phone home
Okay.
and let us know that it's still alive.
All right. So a little bit of a nail-biting wait there.
Yeah.
But I imagine it's going to be so worth it.
Absolutely. I mean, think about it. We're going to be getting data from a region of the sun that's never been explored before.
It's like opening a present, like a cosmic Christmas present,
Right?
full of secrets.
Yeah.
What kind of mysteries are we hoping this data will unlock?
So one of the big ones is the mystery of the corona.
Yeah.
So the sun's corona, its outer atmosphere,
Yeah.
is actually millions of degrees hotter than its surface.
Really?
Yeah, which kind of defies logic.
Okay, so like
Well,
the
right.
air around a campfire is hotter than the flames themselves.
Yeah, something like that.
That is weird. Why is that?
Well, there are a couple of leading theories.
Okay.
One involves these things called nanoflares.
Okay.
Basically, these tiny explosions that are happening all the time on the sun's surface,
Oh, okay.
and they release energy into the corona.
Okay.
The other theory points to these magnetic waves that could be transferring energy from the sun's interior out to the corona.
So it's like the sun has its own internal heating system
Yeah, in a way.
for its atmosphere.
Exactly.
That's really interesting.
Yeah.
So that's the corona, and then
And then there's the solar wind.
yes, the solar wind.
Can you remind us what that is again?
I can try.
Okay.
It's a stream of charged particles
Mm-hmm.
that is constantly flowing out of the sun
Yeah.
in all directions,
Right.
affecting the entire solar system.
Exactly.
And it's responsible for some beautiful things like the aurora borealis.
Yes, the northern lights.
Yes.
Beautiful.
But also for those geomagnetic storms that we were talking about.
Right. It has a dual nature.
Okay, so how is Parker helping us understand the solar wind?
Well, it's actually flying through the solar wind.
Oh.
Collecting data on its speed, its density, and its composition.
Yeah.
So this will give us a much clearer picture of how the solar wind originates and how it evolves as it travels away from the sun.
Okay, so that's the corona.
Yeah.
The solar wind.
Yep.
But there was one more big thing that you mentioned earlier that I want to make sure we cover.
Oh, you mean solar flares and coronal mass ejection?
Yes.
Yeah.
Those are the ones.
Okay, well, let me just say, compared to these,
the
solar wind looks like a gentle breeze.
Ooh, okay.
They are powerful.
I'm intrigued. Tell me more.
We'll have to save that for part 2.
Ugh. Okay, you've definitely piqued my curiosity.
Good. Glad.
We'll be right back to delve deeper into those solar heavy hitters after a quick word from our sponsors. All right, so we're back and ready to talk about these solar heavy hitters.
Yeah, solar flares and coronal mass ejections.
Okay, those were the ones.
Yeah, they're pretty incredible.
Yeah, you made them sound pretty intense before the break, so.
Yeah, I mean, imagine 1 billion atomic bombs going off at once.
A billion.
Yeah, that's the kind of energy we're talking about here.
Wow, okay, that's a lot of energy.
It is. It really is.
So what exactly causes these things?
Well, they're often associated with sunspots.
Okay, sunspots. I remember hearing about those.
Yeah, those cooler, darker regions on the sun's surface.
Okay.
And these sunspots are basically like regions of intense magnetic activity. And when those magnetic fields get unstable, they can release enormous amounts of energy.
And that's what causes the...
And that's when you get these flares and these coronal mass ejections.
So we're kind of like ticking time bombs.
In a way, yes.
Okay, well, that's a little unnerving.
Yeah, but the real question is, how do these events impact us here on Earth?
Yeah, that's what I was thinking. Like, what are the consequences?
Well, the charged particles from these eruptions can bombard our planet.
Wow.
And that's what causes those geomagnetic storms that we talked about earlier.
The ones that can mess with our power grids and satellites.
Exactly.
Okay, so that's not good.
No, it can be pretty disruptive, even dangerous in some cases.
So is there anything we can do to protect ourselves?
Well, that's where Parker comes in.
Okay.
By studying the sun up close, especially during these intense events, we can learn more about how they occur.
Okay.
And hopefully how to predict them more accurately.
So it's like having an early warning system.
Exactly. The more we know, the better prepared we can be.
Yeah, that makes sense.
And I think it's worth emphasizing just how groundbreaking this mission really is.
Yeah.
You know, Parker isn't just snapping pictures.
Right.
It's got this whole suite of cutting-edge instruments on board.
Right, to measure all that stuff.
Yeah, to measure the sun's magnetic fields, the plasma, the energetic particles.
It's like a high-tech detective.
Yeah.
Going out there to investigate the sun's secrets.
That's a great analogy.
And are these instruments telling us anything interesting?
Oh, absolutely.
Oh, okay. Like what?
Well, remember those switchbacks we talked about earlier?
Oh, yeah, like the sun's magnetic field doing the electric slide.
Yeah, the sudden zigzags.
Okay.
Well, Parker has observed that these switchbacks are surprisingly common near the sun.
Really?
Yeah, they seem to originate from the sun's surface. And they might actually play a role in heating the corona.
Oh, wow.
And accelerating the solar wind.
So those weird magnetic wiggles could be the key to solving some of these big mysteries.
Exactly.
Wow.
And here's another surprise. Parker has found evidence of dust-free zones around the sun.
Dust-free zones?
Yeah.
I thought space was full of dust.
It is, but near the sun.
Yeah.
The intense heat and radiation actually vaporize the dust particles.
Oh, okay.
So it creates these clear zones.
So the sun has its own cleaning crew.
Right.
Wow, that's wild. It seems like every time Parker sends back data, we get this whole new perspective on the sun.
Absolutely. It's challenging our assumptions about how things work out there.
And what else has it found?
It's also observed these tiny particles called energetic particles that get accelerated to incredibly high speeds near the sun.
Okay.
These can be hazardous to spacecraft and astronauts.
Oh, wow.
So understanding them is important for space travel.
So Parker's not only helping us understand the sun, it's helping us understand the risks of space travel.
Exactly. It's giving us a whole new perspective on the sun's atmosphere.
It's like we're seeing the sun with new eyes.
Yeah, that's a good way to put it.
What stands out to you as the most fascinating finding so far?
You know, it's hard to pick just one, but those dust-free zones, they really get me thinking.
Yeah.
You know, we always thought of space as just this big, dusty place.
Right.
Then Parker shows us that there are these pockets around the sun where the dust just can't survive.
It's almost like the sun is saying, like, back up.
Yeah.
This is my space.
Exactly.
But these findings are really incredible.
Oh, they are.
It seems like every time we think we are starting to understand the sun,
Yeah.
it throws us a curveball.
It does. That's what's so exciting about science.
Yeah.
It's a constant process of discovery.
Yeah.
And Parker is really rewriting what we thought we knew about the sun.
It really is. We've covered so much in this deep dive. I mean, from Parker's, daring close approach to all the mysteries it's trying to uncover, to the impact this has on us here on Earth.
Right.
I mean, it's clear that this mission is really pushing the boundaries
Absolutely.
of what we thought was possible with space exploration.
It's amazing what we can accomplish when we put our minds to it.
It really is.
And it's a testament to our curiosity, our desire to explore.
Yeah.
I mean, it's not just about collecting data.
Right.
It's about understanding our nearest star, the star that gives us life.
Right, right. And I think that's a really important point.
Yeah.
Because it reminds us that we're part of something much bigger than ourselves.
Yeah. And by studying the sun, we're not just learning facts.
Yeah.
We're gaining a deeper appreciation for this delicate balance that allows life to flourish here on Earth.
And that makes this mission even more important.
Absolutely. The sun is a powerful force.
It really is.
And Parker is helping us learn how to live with it.
Well said. So as we wrap up, I have to ask.
Sure.
What are you most excited to see?
That's a tough one.
Yeah.
Honestly, I'm just excited for the unexpected.
The unexpected.
Yeah, every time Parker sends back data, we get a new piece of the puzzle.
Yeah.
And sometimes those pieces don't fit where we thought they would.
Right, right.
And that's when the real breakthroughs happen.
It's that thrill of the unknown.
Exactly.
That keeps us looking up, exploring.
And pushing the boundaries of human knowledge.
Absolutely. So to all our listeners out there, we want to hear from you.
Yeah, what do you think?
What do you think will be the most surprising discovery from this close encounter?
Let us know.
Let us know.
Yeah.
And be sure to stay tuned for more updates on the Parker Solar Probe mission.
Yes, definitely.
Until next time, keep exploring.